In this question, we have a block of wood that is placed on a horizontal surface, and then we have a bullet that strikes and becomes embedded into the wood. The whole system moves under friction for a certain distance, 8.5 meters, and we want to know what is the initial speed of the bullet. So there are two things happening here. The first is a completely inelastic collision between the bullet and the block. So what we have here is the conservation of momentum. Before the collision, the momentum is mv. It's the momentum of the bullet alone. Afterwards, both the bullet and the block obtain the same velocity v prime. After the collision, this whole system starts to move under friction. So here we need the conservation of energy here, because right after the collision, all the energy is stored in the form of kinetic energy, but eventually it becomes a form of the work done by the friction. So at first, all the energy is kinetic energy, and this kinetic energy equals the work. Work is F times delta x, and F here is a frictional force, which is mu times N, which is mg delta x. So the mass will cancel, and then we get this relationship that v prime equals square root of 2 mu g delta x. Now if we want to know the speed of the bullet, that is, we want to know v, we can get this from these two expressions. So v, if we rearrange the first expression, we get v equals big M plus small m over small m v prime. And then we plug in the second equation to get rid of this v prime. So this is an expression we need in order to find the speed of the bullet. Now we put in all the numbers we know. Big M is 1.35 kilogram plus 0.028 kilogram over 0.028 kilogram divided by 2 times 0.28, that is coefficient, times 9.8 meters per second squared times 8.5 meter. So this equals 340 meters per second. So that is the speed of the bullet.